And welcome to the review lesson, which is 8.10, our last video for Unit 8. So for warm-ups, ladies and gentlemen, I want to make you remember that this test coming up has similar triangles, congruent triangles, and trigonometry, which includes SOHCAHTOA, sine law, and cosine law. So for the warm-ups, let's deal with Unit 7 stuff. And for Unit 8 review, you'll see the handout that your teacher should have given you. Okay, so let's take a look at our warm-ups. What are the similarities and differences between congruent and similar triangles? All right, so let's start off with what's similar. Okay, I'll use SIM for similar. Okay, what do we know about similar triangles and congruent triangles? That what's the same about them is that the angles are both the same. Angles are equal. Okay, between one triangle or equal in both. Okay. Okay. Now, what's different, ladies and gentlemen? I'll use DIF for different. Okay. How do we differ the difference between congruent and similar? Well, what do we know? Congruent triangles. Here's my short form. Congruent triangles have equal sides or side lengths, which differs from similar triangles, where similar triangles have, and you need to remember these two words, proportional ratio sides. Side lengths. Okay, so make sure, folks, that you've underlined and you know what those words mean. Proportional. Oh, I forgot my AL. Sorry, proportional. Let me sit an AL in there. Proportional ratio sides. All right. Question 2. Prove that these triangles are similar and then solve for x. So first of all, whenever we do a proof, you've got to introduce the triangles first. Okay, so I'll go in triangle ABC, and I'll do the same. Watch the order here, folks. Triangle, so A is a blank one, which should match up with H. Okay, so it's going to be H, and then B is 135, so that's got to match up with G, and C, which is 20 degrees, has to match up with F. You have to write them in order, okay? Once you write them in order once, it's easier to do your proportional ratios and connections and whatnot, okay? So in triangle ABC and triangle HGF, let's take a look at what we can find. Well, first of all, can we find angle A? So angle A equals, if you take 180 degrees, subtract 135, subtract 120, that equals 25 degrees, and put down the short form so you don't have to show that work. ESTT. Likewise, we can also find out angle G. So angle G equals, plug that in your calculator, 180 subtract 25, subtract 20, that equals 135, according to ASTT. All right, so now that we've found all the angles, now what we can do is take a look at what angles are equal. So angle ABC equals angle, put it in order, HGF, because they both equal 135 degrees. So there's one angle proved to be equal, and let's prove one more. So let's go angle BCA equals triangle GFH, and they equal 20 degrees because they're both the same. And if two angles in a triangle are the same, so must the third. Now, how do we differ this between similar and congruent triangles? So we have to take a look at a side length. So let's just pick AB, that's a given side length. And does it equal its corresponding side, which is HG? No, it does not. Okay. So therefore, we can now prove that it is similar, because otherwise this would prove that if these two were equal, then we would prove it congruent. So we'll say therefore triangle ABC is similar, remember that's the tilde, to triangle HGF, GF, what we wrote in the intro, and our authority or our property is angle similarity. So you need that for your full communication. Now to solve for x, folks, I didn't leave enough room, so hopefully this warm-up you can fit stuff in. If you printed this off, just hopefully you can get a little bit more room on it. Let me see if I can move this down a bit. Sorry about that. All right, so now we got to solve for angle x. Okay, sorry, side x. Okay, so if I go back, ladies and gentlemen, I can actually look at the triangle, or I can just use my ending statement here. So I'm going to set up my proportional sides because x is a side length. I'm going to go AB over the matching side, which is going to be HG, equals BC over GF equals AC over HF. Okay? Now let's fill in the information that we have. 1.9 over 5.7 equals 2.1 over x, which equals 3.5 over 10.5. Okay, now in this case, we actually have a lot of information. Usually they don't give you this much information. It doesn't really matter. We need to find x. We could use the first ratio to solve it with, or we could use the last ratio. Let's just use the first one. So to find x, we're going to set that up. So it's going to be 1.9 divided by 5.7 equals 2.1 divided by x, cross multiply. 1.9x equals, plug in your calculator, you're going to get 11.97 divided by 1.9 divided by 1.9. Okay, plug in your calculator, x equals 6.3 centimeters. Awesome. All right, one more warm-up, and actually this warm-up does involve trigonometry. Let's take a look. Adam and Kyle both leave CHSS, creating a separation angle of 48 degrees. If Kyle has traveled 1150 meters and Adam has traveled 940 meters, how far apart are they? We're going to assume that they're walking in straight lines. So if this is the school, and we put this one down as Kyle. Okay, Kyle has gone 1150 meters. I put this other one down, ladies and gentlemen, which is Adam. And Adam has gone 940 meters. We know the angle of separation between them is 48 degrees. Okay. And the question is, how far apart are they? So if you want to let this be S be school, or it doesn't really matter, you don't have to label it, but I'll just use S, that's fine. Okay. Now, ladies and gentlemen, look at our strategy here. Do we have a 90-degree triangle? No, so can't use Pythagorean theorem. Cannot use SOHCAHTOA. Do we have a match? Nope. Okay, so we have to use cosine law. Okay, but before we use cosine law, we're going to do our introduction statement. So we're going to go, let S represent distance between boys. Okay. So we're going to find this side S right here, okay? So remember, use your cosine law formula. It's going to be that side squared equals the sum of the other two sides that are squared. Subtract 2 times those two sides times the cos of the given angle, which is 48 degrees. All right. Plug her in your calculators. Ladies and gentlemen, you're going to get some big numbers here, so you might want to double check these when you're dealing with big numbers, okay? So taking a look at the first total, which is the first two terms totaled together, so I'm going to total these two together first. So that's going to be 2,206,100, okay? Subtract, plug that in your calculator, ladies and gentlemen, and you're going to get 1,446,660.37. Okay. Use your calculator. Plug that in to get the difference between it, and you've got 759,439 decimal 63. Don't forget, ladies and gentlemen, you want to get s, not s squared, so you got to square root both sides, and you can do that in your notes if you want, instead of writing it out again. Plug her in, take the square root, ladies and gentlemen. Should be 871 decimal 46. So we could round that to 5 if you wanted. Okay. Actually, it says 46. I'm not sure how the rounding works. You can tell me later on if it's 5 or not. I can't tell you if that had been rounded differently. Okay. So don't forget the therefore statement. So therefore, Kyle and Adam are 871.46 meters apart. I would have accepted 0.5 as well. Okay. Ladies and gentlemen, the next part, we're dealing with a whole bunch of mixed triangle, and this is going to take some time. So make sure you're either going to take a break in the middle, or make sure, I apologize, this is a rather long video in terms of getting everything. I just want to make sure you have a good indication of how to solve these problems. Okay? Remember, your strategy first is to decide if it's a 90-degree triangle, you're going to use a different approach. If it's an oblique triangle, you're using another approach, right? Okay? Just remember, it says here, folks, decide on appropriate formula to solve the indicated unknown. And it says here, number B, folks, to solve for the indicated unknowns in step 1, 3, 5, and 6. I've put it down here, but you may not have it in your handout, so you might need to write in here, solve triangle. Okay? For 1, 3, 5, and 6. All right, let's take a look at example 1. Looking at example 1, ladies and gentlemen, I do not see a 90-degree angle, so we cannot use SOHCAHTOA, we cannot use Pythagorean theorem, so we're looking for a match. Do we have a match, ladies and gentlemen? Not as given, but can we find a match? You betcha. So we're going to use sine law, because we can find a match. Okay, so to find angle B, again, you can either write out the long way, which is this, 180 degrees, subtract 56 degrees, subtract 43 degrees, or you can just write down the second step, which is angle B equals 81 degrees because of ASTT. Okay, either or. Okay, now we have to solve the triangle, so now that we've got our match, we've got the angles all taken care of because we've now found angle B. We've got a match. Okay, so I'm going to put that in my diagram, 81 degrees. Okay, and then we're going to find side A and side C. So why don't we find side A first? So A over sine of 56 equals 38 over sine of 81. Okay. Remember how to do the cross, folks? The opposite cross, which is 38 sine of 56, divide by what you would normally multiply by, which is sine of 81 degrees. Plug it in your calculator, and you should get 31.9 centimeters. Please make sure you're practicing doing these, okay? Plugging them in your calculator. All right, let's find side C now. So C over the sine of C, which is 43 degrees, equals the match, which is 38 over sine of 81. Cross multiply the opposite cross, which is 38 sine 43, and divide by what you normally multiply by, which is sine of 81 degrees. So C equals, plug it in your calculator, 26.2 centimeters. Awesome. Okay, so we've solved number 1. Moving on, number 2. Okay, take a look at number 2. We need to find, hopefully on your handout it says the side C. If not, put it in there. That's what you're trying to find. Okay. It says number 2, look at our strategy. Do we have a 90-degree angle? Yes. So we're either using Pythagorean theorem or SOHCAHTOA. Which one are we going to use? We have 2 sides. We're going to find the third side, so we're using Pythagorean theorem. So C squared equals A squared plus B squared. If those people forget what Pythagorean theorem is. You could have subbed it in right away. You could have given me, ladies and gentlemen, C squared equals 65 squared plus 123 squared. Okay, get a total. Again, that's a big number, 19,354. Don't forget you got to get square root of both sides to get C by itself. And you get 139.1 centimeters. meters. Awesome. 2's done. Let's move to 3. Now 3 is another one that we have to solve, so you might need to write that in. Although it says to find angle A, it still wants you to solve. Okay, so based on angle A is right here, guys. Okay, we've got 3 sides given. So first of all, we don't have any angle, so we can't tell if it's 90 degrees or not, so you can't use Pythagorean theorem. Can't use SOHCAHTOA because there's no 90. Do we have a match? No, because there's no angle given. So we're going to start by finding side A. So we've got to use cosine law. So this is the last law we learned, folks. Okay, we're going to find the angle. Why are we finding the angle? Because this is a description of side, side, side. Okay, so what we need to do is set up cos of A, that's what we're trying to find, equals the other 2 sides, which are the ones that are adjacent to it. So 23 squared plus 33 squared. And then don't forget, you subtract the opposite side. So you've got to remember that. Remember, I'm just going to put that in. Opposite side of given angle, right? So opposite side, okay? Put that in there, okay? And don't forget, we got to divide it by 2 times those 2 adjacent sides. Or the other 2 sides, whatever you want to call it, okay? Plug it in your calculator, ladies and gentlemen. And we have a numerator of 834 divided by denominator of 1518. Remember, to find an angle, you got to use the cos inverse. Okay, plug her in your calcs, guys and girls. Okay, now don't forget, we're not done yet because we've got to solve. Okay, but now we know an angle. So now that we've got an angle, 57 degrees, guess what? Now we have a match. So now that we have a match, now we can use sine law. Okay, so to find, why don't we find angle B first? So let's go sine B over 23 equals our match, which is sine of 57 degrees, what we just found out, over 28. Okay, cross multiply and isolate. So take the opposite cross, so 23 sine of 57 divided by what we would normally multiply by. Okay, to get the angle, remember you got to do the sine inverse of this fraction. Plug it in your calculator, ladies and gentlemen, and angle B equals 44 degrees. Now, ladies and gentlemen, you could do the same thing and find angle C, but I would hopefully you use the shortcut of ASTT. If you know 2 angles in a triangle, you can find the third. So angle C equals 79 degrees because of ASTT. Or show your work if you don't want to remember that property. All right, 3 is done. Moving along. Number 4. Looking at number 4, it says to find angle A. So looking at our triangle, folks, do we have a 90 degrees? No, and hopefully you're annoyed by me saying this. Hopefully this is going through your brain at the same time. So you can't use Pythagorean theorem. You cannot use SOHCAHTOA. Do we have a match? Oh, yes, we do have a match. So we can use sine law. Okay, so to find angle A, we're going to go sine of A over the side length A, which is 26, equals sine 53 degrees divided by the side length which of our match, which is 37. Okay, isolate sine A by doing the opposite cross. And what you normally divide by what you normally multiply by. Remember, you're finding an angle, folks, so angle A equals the sine inverse of this relationship. Plug it in your calculator, ladies and gentlemen, and you'll get 34 degrees approximately. Awesome. Moving on. Number 5. Number 5 again is a solved triangle. Taking a look at the triangle, it does tell us to find A, so we're going to find that one first. And in fact, that's the only one we can find. Let's look at our strategy again. Any 90 degree? No. No Pythagorean theorem, no SOHCAHTOA. Do we have a match? No. Can we find a match? No. So we're using, this is your cosine law, and we're going to use side, angle, side. So cosine law. Just putting these in so you know which ones if you're going back to study from it. Okay, so we're going to find side A. So it's going to be A squared equals the other two sides squared and summed. Okay, subtract 2 times those other two sides times the cos of the given angle, which is 100 degrees. All right, plug it in your calculator, ladies and gentlemen. And if you sum the first two, you're going to get 680. Subtract, be careful here. It says negative 106.96. Here's a quick strategy. This will make more sense in grade 11 when you get there, ladies and gentlemen. But when you take the cos of an angle that's greater than 90, you're actually going to have a negative value. That won't make sense until grade 11, but you got to remember here, a negative times a negative actually becomes a positive. Okay? So plus 106.96. Okay? You'll learn about that when you do your sinusoidal and trig units next year. Okay? Plug it in your calculator, folks. Total it up because you're adding this time. That's a different thing. So make sure, I'll put that in a second. I'll put that in a note in a second. Take the square root, folks. A equals 28.1 meters. Okay. Note, angles greater than 90 degrees will have a negative value. Okay. All right, we're not done this question yet because we need to solve. Okay, so ladies and gentlemen, we now have a match because we now have side A. So why don't we find, doesn't matter, we can find side C, angle C. Let's find angle C. So we'll go sine of C equal over 22 equals sine of our, now that we have a match, sine of 100 divided by what we had for A, which is 28.1. Okay. Plug this in your calc. Oh, so I can't plug it in yet. We've got to get it isolated first. So sine C equals 22 sine 100 degrees divided by 28.1. And we got to get the angle by itself before we plug it in. So angle C equals the sine inverse of this relationship. Relationship, ratio, fraction, all means the same thing in this case. Okay, that's a bad looking bracket. There we go. All right, plug her in, folks. You got angle C equals 50 degrees. Okay, and if you realize you got two angles, you can find the third. So angle B equals 30 degrees ASTT. Now, quick side note, folks. If you happen to not find angle C, but find angle B here, you may have rounded differently. So these may be off by 1 degree, and that's okay. I will take a look at that in consideration. Just depends on your method of solving, so which one you solve first. Because remember, we have rounded these, right, to the nearest degree. So B is based on your result from C, but if you did the opposite way, it would be C would be result based on your result from B. So these could be off a degree or two, and that's just because of rounding. Okay, so no worries about that. I will look into that, and I will still mark, as long as your process is correct, you got your marks there. Okay, 6. Example 6 is another solver. Okay, and believe it or not, we only have one more after this. Okay, so look at this triangle, folks. Notice we have a 90 degrees, so we're either using SOHCAHTOA or Pythagorean theorem. Well, we can actually use both. Okay, so 90 degrees. Let's use Pythagorean theorem to find the side length. So that would be side C. So C squared equals A squared, which is 45 squared, plus B squared, which is 125 squared. Okay, plug it in your calculator and you're going to get 17,650. Take the square root. C equals 132.9 centimeters. Do a quick check, folks, because that's the hypotenuse. Make sure it is greater than the other two sides. Otherwise, you may have made an error there. And it is. Good. So now what we're going to do, folks, is we're going to start finding some angles. And I'm going to find angle B first. Why? Because I've got the opposite side and I've got the adjacent side, so I can use my tan ratio. Okay, so I'm going to go tan of B equals my opposite side, which is 125, divided by my adjacent side, which is 45. To get the angle, you got to do the tan inverse of this relationship. Okay, so angle B equals 70 degrees. And the easy part about this, folks, is to find angle A, we can just use ASTT. So angle A equals, take 180, subtract the 90 that's given, subtract the 70 that we have, and we have 20 degrees, and put in brackets ASTT. Awesome. Okay, one last example. Thanks for hanging on with me, ladies and gentlemen. Okay, here we go. Last one. Problem 7. Determine the length of the indicated side. So we're trying to find x here. Okay, so x is in the right triangle, which I will highlight in red. Okay, and when we look at the triangle, we're only given one piece of information, and that is the 27 degrees. Okay, however, we're given a second triangle down here. And second triangle down here, the oblique one, has more of the information. What I want you to notice, folks, is that there is a common side length here. So here's our strategy. If we can find length BC, or we'll call it D in this case, okay, we will find the answer to get the length of BC. And once we have the length of BC, we have enough information to then go into our right triangle and find x. All right, so what we're going to do here is use common side BC, okay? And I'll let that be equal to side D for now. All right, so D squared, because that's what we're trying to find. Oh, I apologize. Let's go over the strategy for the triangle BCD, okay? Do we have a 90 degrees? Nope, so you can't use Pythagorean theorem, you can't use SOHCAHTOA. Do we have a match? No, we don't have a match, so we're using the cosine law. So let's plug her in. D squared equals the other two sides squared, which is 17 squared plus 15 squared. Subtract 2 times those other two sides times the cos of the given angle, which is 70 degrees. Okay? Plug her in, ladies and gentlemen, and by this time maybe you can take it all and plug it all in the calculator. Okay, if you plug it all in, you're going to get 339.57. Okay, take the square root of that. So D equals 18.4 centimeters. So if I now know that that's 18.4, okay, I now look at my reference angle in the right triangle now, angle 27. This is now my opposite side and my hypotenuse side. And according to SOHCAHTOA, that's the sine ratio. So we're going to go sine of the angle given, which is 27 degrees, equals the opposite side, which is 18.4, divided by x. X is on the bottom, folks, so we do the switch. So x equals 18.4 divided by sine of 27 degrees. Okay. Plug her in your calculator, ladies and gentlemen, you're going to get 40.5 centimeters. So again, if you have two triangles, you're probably going to have to use a common side in order to help you. Here is your homework, ladies and gentlemen. Please read toolkits on page 382, 383, and 461. Do not forget that there's similar and congruent triangles on this as well. I know most of it's trig, but here's your homework, page 382. 4, numbers 2A, 5A, 6 to 8. And on page 461, numbers 1AC, 2AC, 3AC, 4AC. And make sure your calculator's in degree mode. Have a fabulous day!